Well, okay. Hello, everybody. This is Mr. Flanagan, and I'm here today to teach you all about writing formulas of ionic compounds from the names of those ionic compounds. Now, you might ask, hey, come on, Flanagan, what's an ionic compound? Well, an ionic compound is actually also called a salt, and that's made of a cation, usually a metal, positive ion, and an anion, usually from a nonmetal, and that's, of course, a negatively charged atom. And the whole key to writing ionic compound formulas is that the number of pluses equals the number of minuses. Why? Because it's a neutral compound. So, I think we should probably begin. Here we go. Get your periodic table of ions. And you might ask, oh, good God, what is that? Well, there'll be one posted for you on Schoology. But generally, it's a periodic table that shows you the ions that are formed when an atom gains or loses electrons. If you look on the left side of the periodic table, the metals, they're all positive. And on the right side of the periodic table with the nonmetals, they are negative. And look at that. Some of these metals have more than one charge. And that's something that we're going to have to talk about. So, grab that periodic table of ions and let's give her a try. So here's the first example. Sodium fluoride. Well, listen, it's as easy as finding it on the periodic table of ions. There's sodium, Na with a little plus, and way over here is fluoride, F with a little minus. So it really is just a matter of finding them and writing them down. So sodium, Na with a plus, fluoride, F with a minus. Hey, look, the charges match. One plus and one minus. So just jam them together. The formula for sodium fluoride is NaF. Look at you. You're a chemist. All right, let's look at another example here. Okay, what do we got here? Hey, it's magnesium oxide. Okay, periodic table of ions. Trust me on this one. When you find them, magnesium is Mg with 2 pluses. That's because it lost 2 electrons. Oxide is a 2 minus. That's because it gained 2 electrons. The charges match. 2 pluses, 2 minuses. Jam them together. MgO. That is the formula for magnesium oxide. No problem. All right. Potassium sulfide. When you look at your magic periodic table of ions, you'll see potassium is K with a plus. Sulfide is S with a 2 minus. They do not match. Now, you could go this route. I think I'm going to need 2 pluses to balance off these 2 minuses. And so my formula is K2S. See, I'll have 2 pluses balancing those 2 minuses. But you know what? As the years have gone by, I've discovered a much easier method. It's called, dun, 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 crisscross. Crisscross means, well, let's show you. You take the 2 and you bring it down here. That's where I got K2. And you take the 1 and you bring it down here. And that's how I get K2S1 or K2S. Remember, if there's one of an element, we generally don't show that. So if the charges do not match, just use crisscross. It always works. And remember, all you're trying to do is making sure the number of pluses equals the number of minuses. Let's look at another one. Okay, it's aluminum oxide. Okay, good old aluminum. Periodic table of ions. Al3+. Oxide, oxygen with a 2 minus charge. Charges do not match. We've got 3 pluses. We've got 2 minuses. Crisscross. I'm taking that 2. I'm bringing it down here. I'm taking that 3. I'm bringing it down here. So it's Al subscript 2, 2 Als, O subscript 3. And if you really want to get understanding on that, look, you have 6 pluses altogether, 2 of these, and you've got 6 minuses altogether. You end up multiplying them, actually. So 6 pluses balancing 6 minuses It is neutral. Okay, let's take a look at another example. You know what? We're not going to look at another example. Let's take a little break and we'll have part 2 pretty soon.